It's actually a thermometer.
Yes, but it's also makes quite a nice pointer.
Very good.
Easy to grip. Don't look at
Apparently you're cold, Graham. Okay, so next session. Just before we kick off the next session, it was advertised on the forum, and in the hall, in the little warm room where Dave Mann is hiding, is some equipment which is BATC equipment. There's a very nice, and I mean that, 4-channel input video mixer going for a very reasonable sum. The rest of the equipment is probably, if you made us an indecent offer, we'd accept it. It is your club. We'd like to get rid of the equipment. We don't really want the hassle of putting it on eBay. So go in there and have a look, and if there's anything takes your fancy, just sort of shuffle up to us with a couple of quid. And yes, the mixer is 4-channel synchronised input, so it's a very nice mixer. So please go and take a look, and if there's anything there that takes your fancy, let us know. Otherwise, somebody's going to have to take it home and put it on eBay, and we're still looking for a gullible member of the committee to do that. Yeah, I know. Right, off we go again. Oh, okay, good. Right, next, Lawrence. A highly in-depth technical look, complete with spectrum plots of the DTX. Oh, no.
No. I knew there was something missing.
He lost the spectrum plots. Right, RBTV, you've heard all about it on Raspberry Pi. Here's how to do it properly. Lawrence.
Cheers, thank you. Thank you, Noel. Thank you, everyone. Thanks for letting me make this very brief presentation. I've been allocated 15 minutes. I doubt that I shall fill it.
Yeah, we're running 15 minutes late anyway.
But, right, I'll rip on. Right, here we go. Quick history of DTX1, in case anybody doesn't know. It's originally designed to accept analog PAL and NTSC. Goes into usual sort of signal chain like you'd expect, analog to digital conversion. That generates uncompressed video, and then we compress it MPEG-2 using a custom chip by Fujitsu, which incidentally is now obsolete, although we have a considerable number of them in stock. The thing about this is, I actually can't see it, it's not very focused, but about 8, 9, 10 of those pins are parallel transport stream output that go into our FPGA and subsequently on through the analog stuff. Some of this is an extract from my talk last year with some apology, but it basically gives you a brief background of what the DTX1 does. But the thing about it is, we designed it so electric pointer. We designed it so that there was the capability of adding a second transport stream in at this point here. Now, this is an old photograph. The more recent boards have a socket there, and the pins are fitted to the second encoder. Now, the encoder circuitry that we originally developed for DVB-T is MPEG-2 encoder supporting RAM chips. The actual program for this, because it's basically a 400 MIPS RISC CPU, the program for that is held in a little flash chip, which is put into here by the Atmel microcontroller when the thing boots. So basically, it's a kind of a soft MPEG-2 encoder, but the code for it is squirted in by the little microcontroller. And we did design a second board that plugs on top here with exactly the same input circuit, the SVHS socket, composite video and left and right audio in that goes on top of that, which was great and is great and continues to be sold as an entity in a commercial arena for DVB-T, amongst other things. So this is just highlighting that there is a spare 34-way connector on the board. It was pins, but now it's a socket. Interestingly now, that gives us the ability to squirt in streams other than MPEG-2, notably H.264. And as has been noted previously, previous speakers, Pi has a camera, Pi has H.264 compression in hardware this time, unlike the sluggish software approach you would have to do otherwise. So we decided to make a simple board that would take the 264 stream out of a Pi and stuff it into the second transport stream port on the DTX1 for the purposes of reduced bandwidth TV. Now, we can switch off the onboard MPEG-2 encoder because you don't want that running at the same time. You get twice the bandwidth, worse than twice. So it essentially relegates the main board into a power supply for the transport stream dock and all the RF stuff, which is fine. So that's the schematic. It says original transport stream dock. There have been two boards in very quick succession. I'll explain that in a minute why. But basically, that's the connector that goes onto the main board that you saw before. It contains essentially 8 data bits, a clock, a bit to say that this byte is a synchronization byte, so that it can get the packet sorted out where the start of the packet is, and really housekeeping things like power, ground, reset, stuff you don't need in this application other than power and ground really. So the purpose of this board really, it might seem like a non-entity, and in many ways it is. From a functional point of view, it's dumb. It just buffers. I say just, though it's important. It buffers the signals coming in from the Pi, cleans them up. These are Schmidt devices, so any nasty noise on there tends to get cleaned off. It source terminates the drive so that we've got a nice, clean, undershoot-free signal into the FPGA. But its primary reason, actually, is to protect the FPGA from static damage or other abuse that might accidentally occur when we expose that sensitive CMOS input to what you might call the real world. Because in the previous usage of the DTX1, all the signals into the FPGA have been internally generated by us, and now we're worried that people might connect anything here. We don't want to blow up a 50-pound chip, because on top of everything else, it's got 256 Bourne grid array, practically impossible to replace. So if you trash the FPGA, you've trashed the DTX1, unless you replace the main board, which we can do, but obviously it's not cheap. So we thought for a few pounds, and it really is just a few pounds worth of chips there, we might as well buffer it, and while we're at it, put some Zeners to protect against overvoltage. And we've also got a bit of a construct here where we can reverse the direction of the clock so that either the DTX1 can clock in a stream or the external source, such as the Pi, can clock the stream in. So that's acting as a received buffer, that's acting as a transmit buffer. We can either send the clock in or out. It's configured for the Pi to be in. Now, I say there have been two quick issues of this board in quick succession. The first one, which is this one, we built. We couldn't do a lot with it really, because we didn't have any software running on this. Luckily, we got in touch with Everest F50EO, who very kindly turned his transport stream into a parallel stream there. So we get the same 8 bits, the sync bit and the clock bit coming out of here along a nice straight 26-way ribbon, and then, oh dear, we've got a 34-way ribbon and the pins don't line up. Can't be helped, that's the way it was. This was designed as a general purpose, if you like, generic transport stream input. The pin out on that actually adheres very closely to the pin out on the Fujitsu development board where we started the whole project years ago, and you can still actually buy Fujitsu encoder boards which will plug into that, although we haven't actually done it. So some apology, but not a lot for that being a bit wacky, and certainly doesn't fit straight into that. But it became apparent that this was a pain. Like, it really is, having to do all this just to get that into there. So we respun the board, And we've now got a new version of the board, which are actually free today to anybody buying a DTX1. And when I say board, I mean bare laminate. So we've still got the original 34-way header, which is, if you like, a de facto industry standard in some ways. But we've also taken the pins from this and just wired them across to the 26-way D, such that they are in fact 1-to-1. So it's very easy now to get the Pi with its standard camera, just plug a ribbon straight in and off you go. Simple as that. The RF stuff's already all done for you. It's quite a sophisticated synthesizer in there. It can cover 137.5 to 4.4 gigs. And you might think, ooh, so can the DTX1. But it can't, because the output of this synthesizer before it hits the modulator chip, which is here. It's a very good modulator, by the way. You're talking about shoulder 60 dB down. It's very, very good. But we've had to put a harmonic filter on the output of the synthesizer. So at the moment, as supplied, and as Noel mentioned earlier, it runs, the DTX1 will run up to about 2 gigs tops, but it's rolling off even above a gig, because the whole hardware platform this is based on was originally done for DVB-T, up to UHF basically, below a gig. But the benefit of this for reduced bandwidth is we get extremely good signals. Noel can tell you if you're interested, he's done some tests. But it's extremely good. The shoulders are really way down, and the quality of the MAR is excellent. We've now actually done an experiment, and it is very early days. We've taken the harmonic filter off the synthesizer output for use above 2 gigahertz, and there is actually a test unit knocking about with a 2.45 gig output. And if Noel doesn't mind me saying, Noel's got it presently for testing, and it's on a fixed frequency at the moment. There's a test rig. It's running at 2.45 gig. It says there the output's about 7 dB down on the normal output, but excellent close-in performance. You still need external filters, but we're working on that in case there are other uses that might be touched on tomorrow for wanting to go that high. At the low end, we've altered the synthesizer to cover down to 2 meters, even though the data sheet on the modulator says it won't go that low. Well, it does. It may not give you the exact clean signal if you were running DVB-T, but for DVB-S, it's indistinguishably good, and we're very happy with it. It's kind of it, really. It's a bit of a romp through, forgive me. The clever bits are all done in this software. We've got some software from Evereast. Well, we've got some software from Evereast is required, F5OEO, which you can get from his website. I'd just like to thank everybody. I'm not thanking myself, but Carl, my business partner, who's not here today, unfortunately, did the firmware on the DTX1. I've got it in there. If anybody would like their DTX1 reflashed, very happy to do that. No charge at all. Evereast, as I mentioned before, altered his Pi software to bit bash the transport stream out of some I/O pins. Noel's been doing some testing with a gig. It's still an ongoing project. Thank you all very much. Any questions? Yep.
The ones you're selling today, are those already flashed?
No. But I can flash them.
Repeat the question.
Oh, yeah. The question was, are the DTX1s that the shop are selling, the BATC shop, are they flashed already? And the answer is no. It's a beta release, but we believe it works well. We're happy to flash anybody's DTX1 if they wish it to be.
To be clear, that's for the 146 meg. The 2.4 gig stuff is under development and requires hardware mods. So that's not going to be generally available yet.
No.
But the firmware for 146 is pretty much available.
It is, and to support the transport stream dock.
Yeah.
Yeah.
And special show price, as well, and including the transport stream
Yeah,
PCBs.
chucked in for good luck. So
Okay.
yes, yeah.
Any other questions?
One, Lawrence. The problem we were just hearing on the talk previous was about the slight delay with
All right.
the audio.
Yeah.
Is there any problems with the 2 meter version?
The video presently is lagged, let's say, by a considerable amount, and I'm not sure what proportion of that is down to the VLC viewer that we're using. We haven't tried yet the latest software that just came out, the Titoni software with the integrated video.
All of the issues you heard about will apply because the Raspberry Pi is doing the video and the audio encoding. So all that Brian was talking about will apply to the DTX1. But to be honest, for where we are right now, it's not a major issue. You know, it's we're still very much in the experimental phase. And
Oh yeah, and the code that Everest has done will support a USB microphone, such as you might use for Skype on a PC. So if you get one of these little mics or handsets or whatever, stick it into the Pi, that then gets embedded into the transport stream and packed in with everything else and sent
okay, we're running a bit late, so
Yep.
The version without the filter, obviously you're testing it at 2.4. Is there any output at all at 3.4?
haven't tried it. There will be.
I could have a look. Yeah, you'll have to let me have the firmware.
The thing is, though, when I laid the board out, it was several years ago, and it was with a view to working up to a gig, you know, in hotels and things for distributing DVB-T. So there was never any expectation
I'll
it
try
would be needed
if
to
you
run
let
up
me
there.
have the firmware, I can try it.
Yeah, we can have a play, but probably, you know, the synth can go up to 4 and a bit gigs.
Okay. Lawrence is here all weekend, so if you've got any questions, come in and see him.
Sorry, it was a bit
need to,
rompy.
Rush on. Jean-Pierre, if you're ready